All right, everybody, welcome to the video here for lesson number 1 on properties of integer exponents. So one of the things that we went over in class today was all the different properties and rules of exponents. All right, things you should remember hopefully from Algebra 1. A couple of new things, but nothing really that crazy. So for the first one, it asks us to simplify this expression. So what I do is I always separate the numbers and variables out. So as we start to separate this stuff, we can simplify anything that we can see fit. So for 2 over 4, that reduces to 1/2. X to the negative 2 has nothing to reduce with. And then if I look at y to the negative 2 over y to the negative 5, one of the rules we went over was when you divide, you're going to subtract your exponents. Negative 2 minus negative 5 becomes y to the third power. Then I have to look at things that are negative exponents and kind of take their inverse, or not inverse, their reciprocal. So 1/2 is going to stay. X to the negative 2 is going to become 1 over x to the 2, because to make it positive, we just take its reciprocal. Then we go write our final answer here by putting everything up top. So 1 times y to the third is y to the third. 2 times x squared is 2x squared. And there's your final answer. Next one's a little bit similar, but kind of different, right? A bit more challenging because of this initial step here of this negative exponent. So the first thing I'm going to do here is rewrite this, right? So I have 3 to the negative 1, I have x to the negative 3, and y to the negative 1, all over x to the second, y to the negative 4. So again, rewrite everything separate and simplify what you can. 3 to the negative 1 is just going to kind of stay for now. Negative 3 minus 2 becomes x to the negative 5. Again, we're just subtracting those exponents. Negative 1 minus negative 4 becomes y to the positive 3. Then anything with a negative exponent, I take the reciprocal of. Reciprocal of 3 is 1/3, 1x to the 5th, and y to the 3rd. So we wind up having our final answer here of y to the 3rd divided by 3x to the 5th. The next one, again, we just have a lot of stuff going on here. We're trying to figure out how we could simplify this all the way down just to x. So the first thing I would do here would be try and simplify anything I possibly can do on the inside. If you took a different path to get to this answer, it's fine. Just kind of bear with me and see if you get the same answer as me. Don't erase all your work. So the first thing I would have done would have been subtract these, multiply these two exponents. Exponents raised to exponents get multiplied. So x to the negative 2 is going to stay. X to the negative 15 is going to be in the denominator, and that's all still to x to the negative 3. If I divide these, I'm going to do that by subtracting. Negative 2 minus negative 15 is going to become a positive 13. So I have x to the 13 all to the negative 3. So if I distribute that in or multiply that in, I could say this whole expression is x to the negative 39 is equal to x to the a. So I've put it into the form that I want, right? So I could say a is just negative 39. Number two says explain why x to the 0 equals 1. There's a lot of different ways of doing that, right? So if you just put x to the 0 equals 1 because exponents have to have a starting point of 1 because it's the first number in the multiplication process, or when we have x to a power, we wind up having a sequence like we talked about in class. We could do it that way. I'd like to show you another way of doing this to kind of further show you that this all works, right? So 1, right, is anything divided by itself. So if I have x to the 0, and I rewrite that as x to the y minus y minus y is 0. If I subtract something from itself, I have 0. Well, one of the rules that we know is true is if I subtract in the exponent, that's really division. So these two expressions are the same. Right, if I was to divide these two expressions, I would subtract their exponents, which would give me y minus y. Well, anything divided by itself is 1, so that works too. So you can see how there's a lot of different ways of explaining this concept. Obviously, since we've done this a few times, it's a big idea, right? Not something that they would totally ask a lot of questions about on a Regents exam or even my test, but a concept that's going to come up in graphing a lot. The next one says, here's an expression, and it can be written as 2 to the y. Find the value of y and explain how you arrived at your answer. So the first thing I want to do here is I want to simplify everything possible, right? So we have the number 4 can be written as 2 to the second power. So 4 to the third power can be written as 2 to the second power cubed, which can be written as 2 to the sixth power. The number 8 can be written as 2 to the third power. Now, why is all that important? Well, if I can make everything have a base of 2, like this expression we're trying to get to, I could use all my rules of exponents to get there without really having to use a calculator. So in the numerator, instead of 4 to the third power, I can put 2 to the sixth power. And instead of 8, I could put 2 to the third power and have that all squared. I then can use that exponent raised to exponent rule to make this 2 to the 12th power times 2 to the 6th power all over 2 to the 3rd power. I can use my product rule, so when I multiply bases, I add their exponents to make this 2 to the 18th power over 2 to the 3rd power. And then when I divide bases, I subtract their exponents, which would make this 2 to the 15th power, meaning y is 15. Now, could you have done this a different way? Yes, since all of these bases are numbers, I could literally type this into my calculator and see what number I get. It's going to be a really, really, really big number. I then can try and figure out 2 to what power makes that same really, really big number, right? But this method that I chose to use is just using our idea here of all of our exponent rules. Okay, hopefully this video helped. Hopefully you're starting to remember some of these exponent rules as we move forward, because guess what? Tomorrow we get to deal with these pesky things called fractional exponents, which we'll refer to as rational exponents. It's super fun, I promise. All right, hopefully you had a nice weekend, and I will see you all tomorrow.